Hello, I'm Laura. We've covered dwell time in the previous video. In short, dwell time is used to make sure that our game speed is consistent and frame rate independent. If you're not familiar with dwell time, then you might want to check my previous video. The link is in the description. So, you might be wondering, what problem does dwell time have? Is dwell time not enough? To answer that, you might just need to ask yourself, does my moving object involve physics? And what I meant by involving physics is that it doesn't always relate to Unity's built-in rigid body and collider components, but rather whether or not you care about collisions or you need to do some precise time step calculations. If you don't understand about time step calculation, then don't worry for now. Here's an example. You have a bullet as a moving object. The bullet is small, but it's moving very fast. Its radius is 0.1 meters, but it's moving 10 meters per second. The bullet is launched and about to hit a wall that has a thickness of 0.25 meters. If the frame rate is 60 frames per second, then the delta time would be 0.0167 seconds. Hence, the delta movement will be 10 times 0.0167 equals 0.167 meters. When the bullet is about to pass through the wall, the delta movement is less than the wall's thickness. Therefore, it has a chance to check the collision to stop the bullet's movement. If the frame rate is lower than that, let's say 50 frames per second, then the delta time would be 0.02 seconds. Hence, the delta movement will be 10 times 0.02 equals 0.2 meters. And it's still tolerable for the bullet to have a chance to check the collision. But sometimes there are inevitable conditions when the frame rate suddenly drops for a slight amount. Let's say the frame rate drops to 10 frames per second, then the delta time would be 0.1 seconds. Hence, the delta movement will be 10 meters times 0.1 seconds equals 1 meter. In this case, the bullet had passed through the wall without having chance to check the collision, and this might be a huge problem in our game. And this is why in physics calculation, it's very important to have a small amount of fixed time step. If the delta time is too huge, then it should be divided into smaller time steps. The way we do it is using fixed update. So what is fixed update? In Unity, the update method is called once it's framed in the actual frame rate. It's also in the frame where the input and the rendering occurs. But fixed update might be called more than once per frame. In fixed update, instead of using delta time, it uses a special time step which is called fixed time step. We can modify the fixed time step value in project settings, but the default value is 0.02 seconds. In script, we can get the value using time.fixed delta time. So as not to confuse, fixed time step is the same as fixed delta time. On the contrary of delta time that changes each frame depending on the frame rate, fixed delta time does not change. Based on the fixed time step value, the number of fixed update method calls still depends on the delta time value. For example, if the current delta time is 0.08 seconds, then fixed update will be called 4 times, since 0.08 divided by a fixed time step which is 0.02 is 4. If the division left some remainders, let's say the delta time is 0.09, then the remainder is 0.01 seconds. That 0.01 seconds remainder will be kept for the next frame to be accumulated in the next delta time. So if the delta time of the next frame is 0.05 seconds, then the 0.01 value will be accumulated, becoming a total of 0.06 seconds, and then fixed update will be called 3 times. So that's about fixed update. In summary, it might get called multiple times each frame depending on how many steps is the fixed time step contained in the accumulated delta time. So let's go back to our bullet example. Now, instead of moving it inside the update method using delta time, let's move it into the fixed update method using fixed delta time. Now, no matter how the frame rate is, the calculation will be done in exactly the same fixed delta time, which is 0.02 seconds. And since the bullet speed is 10 meters per second, then the delta movement will always be 0.2 meters, and we no longer have to worry about the bullet passing through the wall. Finally, for additional information, if you call time.delta time inside a fixed update, Unity will automatically recognize it and automatically returns the fixed delta time value for you. But still, it's a good practice to explicitly say that you want it to be time.fixed delta time for clarity, especially if you're working in a team. And that's all for fixed update and fixed delta time. I hope you guys enjoy it. In the next video we will cover sub-step update, which is a concept that Unity doesn't provide by default and is inspired by Unreal's stick method. So if you're curious about it, be sure to subscribe because it means a lot, and check out my next video. So thank you very much and see you guys in the next video.